All right, this is the quiz from this week. We took the quiz on 10.5. Identify the following: is scalar or vector? Mass cannot be negative, it's a scalar. Distance can also not be negative, it is a scalar. And wind velocity is a vector. Some scalars: time, speed, distance, mass, volume, energy. Vectors: displacement, velocity, acceleration, force, momentum, torque, I think this is all for first semester. All right, so these are the lists of scalars and vectors, right? There are more scalars and there are more vectors, but these are just a few of the common ones. Time, volume, acceleration. Did I put volume on there? Scalar, vector. A boat travels 8 meters per second north. Right, this is my velocity vector. Against a current of 3 meters per second, right? The current must be going in the opposite direction. When I add these two vectors together, I get 5 to the north. So the resultant vector, right? These are tip to tail, right? How we add vectors. And then from the tail of my first vector to the tip of my last vector, my resultant vector would look like this. 5 meters per second to the north. I should have put some units on there. A velocity vector with a magnitude of 25 meters per second is heading 60 degrees from the x-axis. So I have my quadrant. This is my east, my x-axis. 60 degrees. Wow. That looks more like 45. 60 degrees. So my 60 degrees is in here. My magnitude is 25. And this asks for the horizontal component. What is my eastern direction? All right, this next question asks for my vertical component, right? My northern direction. So my adjacent leg of this right triangle is the horizontal direction. So I want to use cosine to find my x. I have my hypotenuse and I have my theta, so I'm going to multiply both sides by hypotenuse to give me my x-axis by itself. So my hypotenuse is 25, cosine 60 gives me 12.5. We want the y direction, so we're opposite my angle now, so I'm going to use sine. Rearranging my equation, multiply both sides by hypotenuse, giving me with my hypotenuse, which is 25, sine of my angle, which is 60. It must be this. So 60 sine times, yeah. All right. The vector sum of 25 meters north. So 25 meters north would look like this. And 18 meters east. So drawing my vectors tip to tail, I'm adding 25 meters north to 18 meters east. And when I add my vectors, right, my resultant will go from the tail of my first vector to the tip of my last vector, right? I'm finding the hypotenuse here because these are at a 90-degree angle. So I use Pythagorean theorem. It's equal to my resultant squared. And I'm pretty sure it's 30.8. But you can put that into your calculator. The vector sum of 32 meters north and 41 meters west. When adding my vectors, right, I add them tip to tail, and then my resultant is drawn from the tail of my first vector to the tip of my last vector. I use Pythagorean theorem. Just a note about taking a multiple choice test. If we're looking for the hypotenuse here, right, these two numbers are relatively close to each other. So our hypotenuse is going to be something greater, not close to either one of these. If one leg of my triangle is 41, the hypotenuse must be greater than that, leaving me only with this one choice. The direction of the vector sum of the previous problem, right, I want to take my direction away from east. So I need this angle in here plus this angle. So I'm going to use trig functions. I'm going to use cosine for no real reason. Because we have all three, we can use any one. So we need to take the inverse because we are looking at finding the angle. So we want to get the angle by itself. So my adjacent leg, I want this angle in here, so my adjacent's going to be 32 and my hypotenuse is 52. And I plug this into my calculator, 32 divided by 52, and then I do second cosine. Gives me an angle of 52. This angle in here is 52 degrees, but I need away from east, so I'm going to add 90. So 52 degrees plus 90 is going to give me my total degrees away from east, which is 142. All right. How many displacement vectors shown have horizontal components? Number 1 has a horizontal component. Number 3 has a horizontal component. Number 4 has a horizontal component. And number 5 has a horizontal component. There are 4 vectors here out of the 5 that have horizontal components. Vertical components. 5 has a vertical component. 4 has a vertical component. 3 has a vertical component. 2 is completely vertical. And 1 has a vertical component. So all 5 have vertical components. I think in 7th period I asked vertical components that were positive, right? In that case it would just be 1, 2, and 3. Which displacement vectors have the same vertical component, equal vertical components? Right? 3 and 1 have the same vertical component, up and down. Airplane moves 141 kilometers per hour in the northeast. Okay, so I'm in the northeast, 45 degrees. Right, this is my vector. And we want the component that is in the northward direction, just my vertical. So because I've been given this angle, I'm going to use sine. So rearranging my equation, it's my hypotenuse times the sine of my theta is equal to the y, my northern direction. So 141 sine of 45 is my northern component, which is 100.